This is AQA GCSE Chemistry. It is from the 2018 first higher trilogy paper, and this is question 4. The whole question is going to be shown at the beginning of the video, so you can pause and try it for yourself. So here's 4.1, 4.2, 4.3 and 4.4, and finally 4.5, and in total this is a 9-mark question. So let's go back to 4.1. Question is about halogens. What would the state symbol for chlorine be at room temperature? You have got to remember that chlorine exists as a gas. As you go down the group, what you will see going down group 7, bromine would be a liquid, iodine is a solid. So they are changing state as you go down that group. It's a very important thing to remember. On to 4.2, figure 4 represents one molecule of fluorine. Complete the dot cross diagram on figure 4. You should only show the outer shell electrons. Well, let's go through the logical route to make sure that we are happy with how we get to the right answer. Fluorine is in group 7. That means it has 7 electrons in its outer shell. And that means to get a full outer shell, it needs to gain 1 electron. And if it's going to gain 1 electron, it needs to share that electron to get one. It needs to share an electron to get one back, which means it will form 1 covalent bond. So we've got 1 shared area here, each fluorine forming 1 covalent bond. So each fluorine puts 1 electron in. At that point, we remind ourselves that fluorine has got 7 electrons in the outer shell. I've got 1 in here. 1 has already been drawn. That means there are 5 left. And it's exactly the same on the fluorine on the other side. And just to double check it now, this fluorine has got 2, 4, 6, 8 electrons, full outer shell. This fluorine, 2, 4, 6, 8 electrons, a full outer shell. On to 4.3, a fluorine atom can be represented as we see here. What is the total number of electrons in a fluorine molecule? So you've got to read this question carefully. Fluorine has an atomic number of 9. That means fluorine has 9 protons. And because it's an atom, if it has 9 protons, it has 9 electrons. But the question is not about a fluorine atom, it's about a fluorine molecule, and fluorine exists as the diatomic molecule we see here. So we take that 9, we multiply it by 2, and the correct answer is 18. 4.4, aluminium reacts with bromine to produce aluminium bromide. Complete the balanced equation. Now to do this, you've got to know what the formula of aluminium bromide is. And we can use the periodic table to help us. Aluminium is in group 3. That means it will lose 3 electrons to get a full outer shell, which means aluminium ions have a charge of +3. Bromine is in group 7, which means it will gain 1 electron to get a full outer shell. So bromine ions have a charge of -1. Now in a molecule, we want to balance out these charges. So if I've got +3 from aluminium, I need 3 Br minuses to get to an overall charge of 0. And that means in aluminium bromide, I have 1 aluminium, 3 bromines. The formula is AlBr3. Now we can already see we've got 2 AlBr3 based on the balancing that's already been started. So that means I've got 2 aluminiums on the left hand side. And I've also got to look at how many bromines. Now I've got 2 AlBr3s, that's 2 times 3, 6 bromines, which means I need 3 Br2. And finally, moving on to 4.5, when chlorine reacts with potassium bromide, chlorine displaces bromine. Explain why chlorine is more reactive than bromine. So reactivity of group 1 down a group and group 7 down a group, you have got to learn and remember. And they're opposite directions for each one. For chlorine, chlorine is a smaller molecule. And that means the outer shell and the outer electrons, or where the electron is going to come in, is closer to the nucleus. So there's a much stronger attraction. There's also less shielding, pushing that electron away that's being brought in. And that means that chlorine can gain an electron most easily. And that takes us to the end of question 4.